All right, let's jump straight into today's explainer of Chapter 6. We're going to see how festival decorations can literally teach us the magic of math. We usually think of math as just dry numbers on a page, but today we're bringing it to life through a really great story of community and celebration.
Okay, here's our roadmap. We've got getting ready for celebration, counting tens and ones, adding flowers together, becoming a math detective, and finally, cracking the number puzzle. Let's do this.
Section 1, Getting Ready for Celebration. It's so cool how a simple, fun community activity instantly becomes our main math tool for this explainer. Rohan and his friends are busy working together, stringing these brightly colored flowers into stunning garlands for the celebration. But here's the thing, they aren't just stringing them randomly. There's actually a very specific mathematical method to the madness here. Moving right along to Section 2, Counting Tens and Ones.
So, here is the ultimate secret to making math easier: grouping things by tens. Every completed garland you see is made up of exactly 10 flowers. If a flower isn't on a string, it's just considered a single loose flower. Instead of trying to count 60 or 70 individual flowers one by one, and let's be real, inevitably losing track, the friends are grouping them. One garland means 10. One loose flower means 1. It's a wonderfully simple system.
Let's look at how they actually kept track of their progress. They combined tens and ones to find the total quantities. Just take Suwali's row in this breakdown, for example. She made 5 entire garlands, and since we know each garland is 10 flowers, we immediately know that's 50 flowers. Boom. Then she has 3 loose flowers left over. 50 plus 3 gives us 53. It works for the others too. Like Zoha has 3 garlands, so 30 flowers, plus 7 loose ones, making 37. By breaking these numbers down into groups of 10 and the leftovers, counting becomes an absolute breeze.
And all of this illustrates place value. This is a game changer. By understanding that a garland is literally just a 10 and a loose flower is a 1, we unlock the entire system of double-digit numbers. The position of a digit matters. In the number 53, that 5 doesn't mean 5 single items. It represents 5 groups of 10, 5 garlands. The 3 just represents the single loose items.
Section 3, Adding flowers together.
Okay, so what happens when they combine all this hard work? Let's check in with Rohan and Suwali, who really want to know exactly how many flowers they've used together for the festival. They've both been working incredibly hard, and now they want to combine their piles for a massive total.
Before we even touch the math, let's just look at what they're starting with side by side. Rohan has 12 flowers total. That's 1 garland and 2 loose ones. Suwali has a whopping 53 flowers, 5 garlands and 3 loose ones. So how do we add these up without counting from 1 all the way to 60-something? We use our garland strategy.
It's just 3 simple steps. We add the ones first and then the tens. This is literally a foolproof way to solve addition problems. Step 1, we take Rohan's 2 loose flowers and Suwali's 3 loose flowers. 2 plus 3 is 5 loose flowers. Easy. Step 2, let's look at the garlands, or our tens. Rohan has 1 10, Suwali has 5 tens. 10 plus 50 equals 60. Step 3, we just combine the results. 60 plus 5, and there it is. The grand total is 65, proving that working together yields a really beautiful, big result. By organizing the math into tens and ones, a calculation that could have been messy is now incredibly straightforward. All right, Section 4, Becoming a Math Detective.
Time to put on our detective hats. Honestly, spotting mistakes is one of the absolute best ways to deeply understand math. In the source text, there's a character named Daljit who's been doing some calculations of his own, and our job is to verify if his answers are correct.
Just taking a quick look at this list of his equations, some of these numbers look incredibly suspicious. I mean, look at that very first addition problem. 25 plus 36 results in 511? No way. Think about it. If you have 25 loose flowers and someone hands you 36 more, there's absolutely no way you suddenly have over 500 flowers. Something has gone terribly wrong.
So let's investigate. 25 plus 36 equals 511? Understanding exactly why Daljit made this specific error is the real lesson here. He didn't just guess randomly. He actually made a very common, very logical mistake with his place value. Let's break down his thought process. This perfectly shows the danger of forgetting to carry our groups of 10. Here's exactly what Daljeet did. He looked at the ones column first. 5 plus 6, that's 11. So he wrote down 11. Then he looked at the tens column. 2 plus 3, that equals 5. And he just wrote that 5 right next to the 11. He literally pushed the two numbers together to make 511. But think back to our garlands. When you have 11 loose flowers, you have enough to string together one brand new garland with one flower left over. You've got to carry that new 10 over to the garlands column. So 2 tens plus 3 tens plus the new 1 10 we just made equals 6 tens. The correct answer is 61. The text tells us to correct it if you find them wrong, and that's exactly what we did. We verified his work, found those tricky place value mix-ups, and proved we are excellent math detectives. Honestly, fixing a mistake like Daljeet's teaches us way more about place value than just getting it right the first time ever could. Finally, Section 5, Cracking the Number Puzzle. Right at the very end of the chapter, we get this fascinating puzzle, a circle of numbers connected by lines and rings. It kind of looks like a wheel with numbers on the outside rim and numbers on the inside. Our mission is to figure out the hidden rule connecting them. When we extract the numbers into this format, the logic of the puzzle just jumps right out at you. Adjacent numbers on the outside of the diagram add up perfectly to the numbers directly between them on the inside. Look at the first pair. We have a 3 and a 9 on the outside. Directly between them on the inside ring is a 12, because 3 plus 9 equals 12. Keep moving around the circle. 9 and 6 on the outside connect to a 15 on the inside. It's an unbroken chain of addition, proving how deeply interconnected numbers really are. Just like these two mice unlocking their beautifully wrapped gift for the festival, we've successfully unlocked all the math secrets inside this chapter. We started with community decorations, turned them into real tools for understanding place value, learned exactly how to carry our tens, and finished off by breaking the code of a numeric puzzle. So I'm going to leave you with this final thought. Look around your room right now and ask yourself, how many groups of 10 can you spot? Whether it's stacks of coins, a row of books, or even the apps on your phone screen, our whole world is organized by tens. Once you start looking for these hidden garlands of numbers in your daily life, you'll realize math isn't just stuck in a textbook. It's literally everywhere, helping us organize and make sense of our world.